Hello students, in this video we'll look into the next topic of laws of motion, that is connected bodies. So how we apply this laws of motion to connected bodies. Now first let's look at a simple example of connected bodies in horizontal plane. Now if there are two bodies, you can see that a person is pulling the two bodies. Now let's say he is applying a force F on it, right? So tension here I'll say it is T2 and tension here I'll say T1. Now what will be the acceleration? Acceleration would be equal to total force by total mass, that is equal to m1 plus m2, right? This is acceleration. Now because at this point the force is applied in this direction, so tension is here, tension will be acting like this, so force is acting like this. So I can say tension T2 equal to applied force. I want to find T1. What is T1 equal to? M1 into A, because T1 is only pulling this part. So I can say T1 equal to M1 into A is how much? F by M1 plus M2. So in that case, what will be tension T1? T1 would be M1 by M1 plus M2 into F. Now this is a situation where the bodies are connected by a string. Now sometimes there might not be a string, there is only masses might be there. Let's say I have mass M1, M2, M3. They are in contact with each other. Now I am applying a force F on this. I'll call this as mass 1, this is mass 2, this is mass 3. Then what will be the acceleration of the system? Acceleration of the system would be F by M1 plus M2 plus M3. Now what is force experienced by 3? Force experienced by 3 is M3 into A. So who is applying this force on M3? M2 is applying. So I can say force applied by M2 on M3 equal to M3 into A. Now similarly, if I want to find what is force applied by M1 on M2, M1 doesn't know that there are two bodies M2 and M3. So it is pushing both the bodies. So I can say force applied by M1 on M2 equal to how much? M2 plus M3 into A. This is the force applied by M2, M1 on M2. So the normal reaction on M1 would be just the opposite of it. Similarly, the normal reaction on M2 would be just opposite of this. So this is in case of the bodies which are on horizontal plane. Now let's look at the systems which are in vertical plane. So something like this, let's say this is a surface to which there is a massless pulley. Now the strings and pulleys are massless, I can say T1 equal to T2. So I'll take T1 and T2 to be same, both as T each. Now there is W2, W1, I'll name them as M2 and M1. Let's say if M2 equal to M1, the net force is 0. So both the system would be in equilibrium. However, if M2 is greater than M1, what will be W2? W2 is M2G, W1 is M1G. Then what will happen? M2 would come down with acceleration A and M1 would go up with an acceleration A. Now if I want to find acceleration of the system, how do I write it? I'll write equation of motion for the part for mass M2. Net force on M2 is M2 into A, that is downward. So that is downward force, that is M2G minus upward force, tension. Now similarly, if I write equation for M1, M1 into A is upwards. So net upward force equal to upward force minus downward force. I'll subtract these two, add these two expressions. So what will I get? A into M1 plus M2 would be equal to G into M2 minus M1. So what will be the acceleration of the system? Acceleration would be G into M2 minus M1 by M1 plus M2. This is the acceleration with which the heavier mass goes down or the lighter mass goes up. Now I want to find tension. So how do I find tension? I can take one of the expressions. Tension T can be written as, if I take M2, it is going down. So I can write M2 into G minus A. So that is T equal to M2 into G minus G into M2 minus M1 by M1 plus M2. So that can be written as, T is equal to M2G, I'll take it out. I'll be left with M1 plus M2 minus M2 minus M1 by M1 plus M2. right? So from this, what do I get? M2 and M2 cancels. So I'll be left with M1, 2M1. So this will become T equal to 2M1 M2G by M1 plus M2. This would be the tension in the string. This is in case of, the two bodies connected vertically. This situation is also known as Atwood's machine. The next case that we have is a hanging mass. Let's assume that it's on a frictionless surface. Then let's see what are the forces acting on it. M2G is acting downwards. So there is a tension T here. Now let's say this is moving with acceleration here. This will also move with acceleration here, and tension T is acting here. So for the case when it is frictionless, if it is frictionless, what will happen? I don't have to bother about anything. I can directly say, I'll write equation of motion for M2. What is equation of motion for M2? M2 into A equal to M2G minus T. And for M1, M1 into A equal to T. Add both of them, I'll get A into M1 plus M2 equal to M2G. Or A equal to how much? M2G by M1 plus M2. Now this is the normal way in which we can do it. Otherwise, if I want to directly write down the expression for acceleration, what I can do, I can divide the net force. What is the net force? M2G by total mass. What is the total mass? M1 plus M2. I can get it that way also. So if I want to find tension, tension equal to how much? M1 into A. So tension equal to M1 M2G by M1 plus M2. Now the same situation if friction is considered. Now it's not frictionless. Then there will be a frictional force acting like this. Now what is frictional force given by? Mu M1G. Then what will be the expression for motion for M2? M2A equal to M2G minus T. That doesn't change. Now expression for motion for M1A, M1A will become T minus mu M1G. In that case, what will happen? If I add both of them, A into M1 plus M2 equal to how much? TT cancels, G into M2 minus mu M1. So what will be the acceleration in this case? Acceleration is G into M2 minus mu M1 by M1 plus M2. So in this way, we can find the acceleration for a situation where the friction is present as well as friction is absent. So this is when we have one of the masses hanging and the other mass is on a horizontal surface. Now let's look at a situation where we have a wedge. Now here, let's say this is 30 Newton, I'll say G, so this is 3 kg, or I'll take it as M1 and I'll take this as M2. Now let me find out the forces acting on this. This would be how much? This would be M2G. This would be M2G sine theta. If I take this as theta, this would be M2G, and the force which is perpendicular to this is M2G cos theta, right? Now let's first consider a situation where friction is not there, frictionless situation. So if it is frictionless situation, tension T is acting. Let's say M1 is very much heavier and it comes down, the system moves like this. M1 moves down with acceleration A and M2 moves up with acceleration A. Then for M1, I can write M1 into A equal to M1G minus T. For M2, I can write M2 into A equal to T minus M2G sine theta. So add both of them, I'll get A equal to M1 plus M, A into M1 plus M2 equal to G into M1 minus M2 sine theta. So what will be the acceleration? Acceleration is G into M1 minus M2 sine theta by M1 plus M2. This is what is the acceleration, right? Now I put this acceleration in one of the equations, I can find tension. Now if friction is there, in that case what will happen? With friction. So equation of M1 doesn't change, it will remain as M1A equal to M1G minus T. Now what will happen to equation of T2? There will be a frictional force acting downwards in this case. So in that case I can write M2A equal to T minus M2G sine theta minus mu M2G cos theta. So if I add both of them, I'll get acceleration as, I'll take out G and this one would be M1 minus m2 sine theta minus mu m2 cos theta by m1 plus m2. This is what is the acceleration. So these are the cases, what with friction and without friction, where I can find acceleration in case of a wedge. Now I can have various situations. We cannot discuss all the situations here, but this is the way we do it. There can be a combination of inclined plane and a vertical one, inclined plane and a horizontal surface, both inclined planes. But whatever is the situation, if you want to write expression for acceleration directly, acceleration can be written as net force by total mass acting on the system. So that is what is there in case of connected bodies. Hope you could follow this. Thank you very much.